Okay, so now we're recording. So let's see. We want to go back to. Oh no, I want to share the whole screen. Share screen. Entire screen. Why is there two screens? Let's make one workstation. It's probably confused. Close. Cancel. Share screen. Hmm. It looks the same. Oh, I think I just have a mirrored screen. I have a mirrored screen. It's showing the one on the board. That's what's going on. Okay, so it's mirrored. Got it. Now I know what's happening. Okay, homework 4. After all that. Yeah. Okay. So again, I'll try to split this up into 2 halves because probably we'll be using StatCrunch. So I'm gonna open StatCrunch also and then just put that on the other half of the screen. Okay, so we're doing proportion stats on this one. So X is our number of successes and N is our number of trials. And then the 90% confidence interval is key. So this table is just giving you the old fashioned table of Z-scores. We're going to be using a calculator on StatCrunch instead of doing the old school method. So we want to do proportion stats because we just have a one sample proportion. And this is summary data. The 538 out of 1001 is just already got all the data counted up for us. So with summary, our successes being 538 and the observations being 1001. Again, yours will be a bit different. And we're not doing the hypothesis test, we're doing the confidence interval. And you want that on standard walled, and we just want that at 0.9. If yours says a different confidence interval, you want to use whatever percentage they have there.
So you went to StatCrunch and one sample prop summary?
So proportion stats and then one sample. So there will be some 2 samples. They'll be toward the end of the homework. And then we compute. And it gives us our sample proportion. And then the confidence interval is the lower limit and upper limit. So this is what's guaranteeing us that we have a 90% confidence that the true value of the proportion is between these 2 limits, the lower limit and the upper limit. And the standard error is, yeah. Well, we can calculate the actual error, but the standard error is like the sample standard deviation. So it first asks us what's the best point estimate. So the best point estimate is just that sample prop to 3 decimal places. So for me, that's 0.537. And then the margin of error. So the margin of error, there's a couple ways to do it. I'm going to do just the upper limit minus the sample prop. Because the sample prop is right in the middle of the upper limit and lower limit. If you can imagine that, like imagine the upper limit being the end of the tail, the sample prop being the middle of the bell curve, and then the lower limit being the end of the left tail. So if I just do like my G calculator, that's just my little silly computer calculator here. I can just do the, for this one, 0.563 38 minus 0.53746, and I get my error of 0.0259. That's what I'm putting in here. 0.026 actually, because it only asks for 3 decimal places. All right, the confidence interval is easy. We're just copying the lower limit and the upper limit. So 0.512 is mine. And 0.563. And then the last part is just interpreting. So the thing you want to look for when you're doing these is it's not that there's some sort of like 90% chance it's equal to this. It's that there's a 90% chance it's in these bounds. So to me, that looks like A. There's a 90% chance the true value of the population will fall between the lower bound and the upper bound. So why am I interpreting that wrong? One has a 90% confidence. So A and D sound so similar and they're really easy to mix up. But notice that you have a 90% confidence. There's not a 90% probability. So the key is in the wording. Both of them say that they have the true value between the lower bound to the upper bound. My eyes just scanned for the word true value so quickly. I overlooked that A and D both say true value. So true value is going to lower you down to, it's going to give you a 50-50 chance on these multiple choice questions. The thing that you want to keep in mind to distinguish between which one's right and which one's wrong is that you have a 90% confidence, not that there's a 90% chance. And that'll give you the right answer. Okay. So we may split this module up into 2 parts. I think we're going to. So if there are 16, we'll just try and make it through the first 8 today since we had so many technical difficulties. Now, one thing that's nice is I can leave everything as is because I'm going to be using the same sort of calculation. So what I can do, instead of going back to stat calculator, I can do options and then edit. And then I can just edit my successes and my observations. Does that make sense? So in this one, it says there's 1,050 surveys returned, and it should always be the smaller number on top. And then 2,475 surveys are the number of total of observations. And we just want a 90% confidence interval again. So we're doing the same exact computation. I click compute and I get all my same numbers. So the point estimate, I can type that in. That's the sample prop, 0.424. I get that answer. And then the margin of error, that's where I want to use my calculator down here. So I will just clear everything and I will go the upper limit minus the sample prop. So 0.44058 minus 0.4242, and I get 0.016. Okay, the confidence interval, I'm just typing in the lower limit and the upper limit. So 0.408, notice I need to round up on my numbers because after the 7 comes a 9. And then on the second, I have 0.441 because after the 0 comes a 5. Okay, so let's see if we can do that right this time. So if we look for, so we see true value is in A, and we also see that there's true value in B, but we know that A has confidence and B has chance. So we know the answer should be A. See how you can kind of like eventually just work it down to a systematic set of rules. But the takeaway in terms of understanding is this is not giving us a probability. It's giving us some sort of confidence. This isn't a mathematically precise notion as probability. Okay, this one really easy. Just construct one part. We're just constructing the confidence interval. So we're just again going to go to options and edit. So we have 859 total births and 426 boys. So actually, my sister had so I have two sisters, and they've had all boys so far, 5 boys. And this morning, my older sister Jody just had her first girl. So I now have a niece. I've yet to meet yet. Yeah, her name is Willa Sunday. So yeah, she came to us at 7 a.m. this morning. Anyway, notice that this is a 95% confidence interval. So we're still doing the same test, but we're changing this 0.9 level to 0.95. And then we're computing. I forgot to change. I got these backwards. So remember, like I said, the smaller number should be on top. So 426 on top and 859 on bottom. So compute there. And now we just have to enter the confidence interval. So that's just the lower limit and upper limit. So 0.462 and 0.529. And we get our answer. Okay. Do these, so it says, it is believed that the proportion is 0.506. This sample is 0.459, and 0.506 lies in this threshold. It's within the normal threshold that you would expect to see 95% of your things happening, or that you have 95% confidence that a number should be between here and here. So 0.506 is between 0.462 and 0.529. So this is totally normal. So that means there's not going to be strong evidence. So amongst the answers, it would be the not strong evidence answers. And it is contained in the interval. So notice A says it's not contained, but it is contained because this number is between your lower limit and your upper limit. Okay. Okay, again, we're going to do a confidence interval. So options edit. This one, notice they don't give you the total. They give you that there's 442 green peas and 167 yellow peas. So let's quickly see what that total comes out to. 442 plus 167. That comes out to 609. So they say we want to do an interval to estimate the percentage of yellow peas. So yellow peas, there are 167 of them. And total, we just calculated, there should be 609 of them. So we compute, and we want to do our interval again. So still 3 decimal places, 0.239 for me. And the second one should be notice the 6 bumps the 9 up to a 10, so 0.310. Okay, so the next part, what does it say? Based on the confidence interval, do the experiments appear to contradict the expectation that 25% would be yellow? So that's kind of funnily phrased. So no, it's not. We have the same issue. 0.25 is right between the lower and the upper. So yeah, if you guys gotta take off, I'll remember. No. Yeah. Like I said, we're just gonna go through 8 today, and then we're gonna do the next half on Thursday. This is recording. So this be this one. No. Yeah. Sorry for all the problems. Yeah. Yeah. Okay. back to options edit. Yeah, so we should still be on this whole type of thing for today. One sample stuff. Next time we'll get into some of the two sample. Okay, so in a poll of 514, it says 45.7. So we can use a little math to figure that out. Let's go ahead and take that 514 and then let's multiply that by 45.7 as a decimal point 457. And notice we get 234.89. So we're going to assume 235. It says round to the nearest integer. So we multiplied to get that answer for part A, just the percentage as a decimal times the total. And I'm getting 235. Now we want to construct a 99% interval based on this. So I'm assuming we're going to use that value 235. And we're going to use 514. One thing that's interesting, notice the size of your interval and your confidence level. They're inversely proportional. They have an inverse relationship, because if you want to have a 99% confidence that your interval contains some number, if you have higher confidence, that interval needs to actually get wider, right? To include that. So we would expect a bigger interval for 99% than we would for 95%. So again, we have 235, 514, and we want to change that level to 99, and we compute. But let's just do that. Let's check that real quick. Notice for 99%, we got 0.4005 and 0.513. Notice what happens if I edited that and made that a 95%. We actually got a smaller interval, right? We got 0.41 and 0.50. So it gets wider when we make that confidence interval go up. So 0.401 will be the first number. And the second number, 0.514. Okay, so then it says repeat using 80%. So again, we can edit and just change that 0.99 to 0.8. And notice we're getting a much tighter window, 0.429 to 0.485. So notice the 80% confidence interval is not wider, it's narrower. So the 99% confidence interval is wider. Okay, so it's either C or D. So a confidence interval must be wider in order to be less confident. A confidence interval must be wider to be more confident, right? To have more confidence that you're going to lie between some values, you want it to be wider. So that's going to be C. Okay, this one is interesting. This one we're actually going to be using a different feature on StatCrunch. So let's see if I can remember how to do it. So for this one, we're going to go to Stat. Let me make it the whole half. Stat. Proportion stats, one sample. And then I think we do width sample size here. Okay. So we need to fill in these parameters, and this is fit that to the screen there so we can see everything. Okay, so it says assume nothing is known about the rate of e-cigarette usage. How many adults must be surveyed? So to figure out, basically we're trying to figure out the survey side. So that we want a confidence level of 90%. So we know the confidence level should be 0.9. And a margin of error of 1. So if the margin of error is 1, then that means the width should be, so you have the margin of error on either side, right? Because this is a dual-tailed thing. So I think that the width should be 0.98, which it's already pretty close to. And if nothing is to be known about the rate of e-cigarette usage, I think we just leave that at 50%. That's the target proportion. No, something about that's wrong. That's what we're trying to figure. N is the sample size, and that's what our answer is trying to be. Let's just check this to make sure. I don't think this is going to be right, but yeah. So we have this complicated thing, but the width maybe should be based on this. So this result is based on 36,000 adults. That doesn't have anything to do with ours. We're trying to figure out how many we actually need. The target proportion maybe is not 0.5, but maybe we do 1 minus 0.371, which is 96.29 or 0.9629. No, that's wrong. Let's keep this at 0.5 and let's make that margin of error of 1 percentage point. Maybe we make that 0.01 or 0.02. See, and then we're getting something more realistic. So if we entered 0.01, it's going to round a little bit. Notice this isn't perfectly 0.01, but it's very close. Let's try this number. I'm always a bit forgetful on using StatCrunch on this specific feature because it only comes up in this one specific module in this one specific setting for proportion stats. Okay, so let's try 0.02 here again for dual-tailed, and I think we're going to get the right answer. 6,764. I bet that's the right answer. 6,764. Okay. So see, I have to tweak it a little bit, but let's go. Let's do this one again. Well, the use the results from the 2014 study. They used 36,000. If you knew a little math, you could save some time. Or wait, what is it saying? And 2014. Maybe I have to multiply 0.3071 times that. Let's do that real quick. Sorry. But we'll walk back through this one again. For that reason, but let's see if that's what is going on here. So 0.0371 times 36,000. We get 1335.6, or it says nearest integer, probably. So they want 1336. If I have to double this, I'm going to be a little bit floored. Yeah, so let's multiply this by 2. 2671 maybe. $967 there. Huh? How do we get 967 from that? Anyway, so let's go through this again. Does the result from the 2014 have much an effect on the sample size? Oh, it's because we were supposed to change the target proportion, I bet. So excuse me. Let's see if we can get 964 real quick, and then we'll go over this again. I'm a little bit shaky on this problem. So target proportion, let's say 0.0371. Confidence level point. Yeah, look, then we get 967. Okay, so that was the issue there. So does the result have much of an effect? Yeah, you significantly reduce the sample size, dramatically reduces it. Okay, all right, so I was shaky as heck on that one, so let's go back and redo it real quick. I think we have enough time. So similar question. Okay, so let's walk through back all of this so we have it cemented in our heads. So on this one, they're asking us with some information to figure out how many people we should sample. Okay. So we're going to go to proportion stats. Everything in this module 4 is proportion stats. This one is width and sample size. If you hit this button, it fits into the screen a little bit better. Okay, so our confidence level in this problem is 0.99. So I'm going to change that to 0.99. And then the margin of error is 2 percentage points. So margin of error is on either side of your point estimate. So you always have to double it. Okay. So our margin of error, we want to change that to 0.04 instead of 0.02. And then we compute. The part where it says assume nothing is known about the rate of e-cigarette usage is not taking into account this 3.66%. That is from this 2014 survey that we're going to use in part B. So we just leave it alone as 0.5 and we hit compute and we get our answer of 4147. Okay. And then for part B, what we do is we change that 0.5 to this 3.66 percentage, but as a decimal. So 0.0366, we compute that and we get our sample size of 585. And we see that dramatically reduces the amount of people we would have had to sample. So yes, it dramatically reduces the sample size. Okay. So sometimes struggling through it once is okay because the second time you go through it, it really sticks in your head a whole lot better. Okay, so use the results. 78% rate themselves as above average drivers. We want to test the claim that 7 out of 10 are above average. Identify the actual number of respondents who rated themselves as above average drivers. Okay, so we can go back to just using a regular old calculator to figure that out. So we can do our 1057 times our 0.78. And that'll be the number from the survey that thought they were above average. So rounding to the nearest whole number, that's 824. And then identify the sample proportion and use the symbol to represent it. The sample proportion is going to be p hat. P with the little kind of caret on top is the sample proportion. And the thing that represents it from the sample was the 78%. So that's 0.78. So we're comparing that to this 0.7. That's how we're going to be using the hypothesis test. So we are doing something a little bit different. For the other ones we were doing, so we can still do options and edit if we want. Oh, no, we can't because we were doing the width thing before. So let's go ahead and go to stat. We're still under proportion stat. We're still under one sample with summary, but now we're actually using this hypothesis test instead of this confidence interval. So for the hypothesis test, our successes were the number we entered before in part A, which was 824, thought they were above average drivers out of the 1,057 total observations. And what are they wanting us to test? For this first part, they just want the test value. So the test value is P, we want to know is the population value actually equal to the claim of 0.7. And that's it. Okay, so that's basically just asking you how you do a hypothesis test. This next one is going to be setting one up. In general, when you're doing a hypothesis test, it's always going to be set up as equal to some claim number. And then you're going to have to look for a clue word. They'll say different, you'll put not equal. They'll say greater than, you'll put greater than, or they'll say less than, you say less than. So you always need to look for a key word to see which one of these you're testing, because it's going to be the difference between looking at a two-tailed proportion, to the left proportion or to the right proportion. Okay, so the claim here, the claim is 28% is what it's equal to. So if it says equal, we're going to be looking for equal and not equal. 21% is our observation. So the first part, we're looking for equal, 28% not equal. Now, when we're doing our hypothesis test, the first one is always equal. The second line is where it can change between not equal, less than, or greater than. So we know we're looking for equal to 0.28 and not equal to 0.28. So it's got to be C. B doesn't make any sense at all because the first line always has to say equal. Does that make sense? Okay. And then the test statistic. So what we want to do is we want to run this experiment. So our successes in our experiment, we had 21 candies that were colored out, or 21 candies that were blue out of 100 candies that are colored. Let's say these are M&Ms or something like that. And then the test we said is 0.28 and not equal to 0.28. So we compute that. And the test statistic is the Z stat right here. And you do need to include that negative. So we want to do minus 1.56 are my numbers. And then the p-value is given right here. All three decimal places, 0.119. And then the null and alternative hypothesis, if they don't say anything, we're doing it based on that 5% number. So if it's less than 5%, we reject. If it's bigger than 5%, we fail to reject. So this is bigger than 5%. We're going to fail to reject. If you fail to reject, there's not sufficient evidence. This one says fail to reject not sufficient. This one says fail to reject is sufficient. So we know it's choice B. Okay. So we will stop here. We're halfway done with the homework. We'll finish the homework next time. So I'll go ahead and stop the recording and take attendance for today. So let me make sure it's my first time using this one. We want to stop sharing. And let's stop the recording.